Wow. What? What? Oh.
Oh, you're here. Oh, good. Yes. From like the north to south. That's crazy though. Yeah, I'm not sure. They don't have they can have different hours.
All right. Okay. Hey, everyone. Just kind of logistics. Quizzes. I'm not going to have a quiz today, but there might be a quiz tomorrow. Who knows? So quizzes work the same way as in the ESC190. So best 8 out of 12. Kind of the same style as well. So there's readings. We are currently using so there's kind of 3 official textbooks that are kind of recommended, not required. I'm gonna post the readings, and I have posted the readings. They're not mandatory. They're more like if you want to read another perspective. So the books are quite different. So the King book, really, we used this book when we were teaching ESC180 back when we taught ESC180 in the C programming language. So it's more like an introductory programming textbook that's in C. So for that reason, you'll see that the readings for like the first 3 weeks are like a lot of chapters. And in part, that's because the book is not exactly for 190. The book is really for 180. It's just that that's what exists. At the same time, that means that if you feel like you're struggling and you need like a fundamental review of something, that might be a good way to go. So another book that's listed, and really I'm not going to be referring to it very much, is Kernighan Ritchie. So this is Kernighan, this is Ritchie. So Kernighan is so currently professor at Princeton, graduated Angsci in, I don't know, like in the 50s, I think. So famous person, and this is like a famous classic book. It's not really written in a super accessible style, I would say. It's fair to say. Like, he doesn't use it when he teaches either. But it's, you know, kind of part of the culture. And also Kernighan is an Angsci grad, so we included that. I'll sometimes refer to it, but kind of very rarely. I'm not going to list readings in it, but if you want to read something that's like extremely concise and written from the perspective of someone who, like, both of them were actually involved in designing the programming language as well, that might be a good source. Skiana is not currently relevant. It's going to be relevant in the second half of the course. The other thing that we have is we've been building lecture notes for ESC190. Those currently are more like last year's materials than this year's, but quite similar. So we are going to try to update them in real time to reflect exact kind of things lecture by lecture. But for now, this is kind of, if you want a text summary of what we've been doing in the slides with the examples, that's a good way to go. Right. So I'm also, some people kind of like having those learning outcomes. I don't know necessarily that learning outcomes are useful, but like if you want to know kind of what I'm aiming for, the learning outcomes are listed here. All right. And then, yeah, so like all the dates are in here. So there's going to be an online lab posted within a few days. Again, kind of in a similar style to ESC180. So the online lab is just to make sure that everyone has compiled something and has run something, because if people work in pairs, we don't necessarily know. Project 1 will be due February 14th, will be posted once we have all the material that you need for it, which I hope is going to be tomorrow, but possibly Monday. All right. So depending on how far we get. Everything else works the same way as ESC180. Okay. I wanted to talk just a little bit about kind of, now that you kind of know a little bit about what's going on in ESC190, I wanted to talk about how and why, and how it's different. So one thing that you will have seen, you know, this week, last week, is C is much more flexible than Python in the sense that there is like more things that you can say. So anytime that you use a variable, you can say like address of, or you can say go to that address, or go to that address and then treat that as an address and go there. We'll see examples like that today, right? And in Python, those are just like, there's no options. Like if you have an integer a, all you can do is you can reassign something else to it, or you can assign it to something else. There's not much that you can do. So that means that in Python, although there are situations where you need to think about the memory model, right? When you need to predict something tricky with aliasing, stuff like that, a lot of the time, there's just like not a lot of options. Like if you kind of know what you want to do, there's only one possible way to do it in terms of assigning values. In C, as you saw, that's not the case. You need to make those decisions all the time. And if you make the wrong decisions, not only won't it work, it won't even compile, right? So in a way, we've already done a lot of this material in Python. It's just that in C, it's much more essential. So it's not just about kind of those edge cases where you have aliasing or like nested lists, stuff like that. You need to think about this all the time. So we'll kind of keep practicing that. And I would say like this is a little bit like math, and it's a little bit like programming. So in the sense that you need practice, and for that reason, we'll have, like the 50 exercises that we started doing. So some of them I'll do in class, some of them you'll do by yourselves, like the pointers exercises. Some of it is like a little bit like maybe what you see in Math 185, where you really need to kind of like assimilate this new frame of thinking about things. Okay. At the same time, the main goal here, apart from teaching you this and that, is to just get you to program, right? And in that way, C programming is the same as Python programming, and the same as what they said in 180 applies. Like the more you program, the better you get at it, and that's the only thing to say, really. So why are we doing this? Isn't C an annoying kind of language? Well, yes, kind of. But C programs can be much more efficient than equivalent Python programs. In part, that's because compiled languages are generally faster. And that's because the compiler can kind of look at the code you've written and say, okay, like, given that they know everything that you're doing there, how can I make it so that it's faster? Python kind do it because Python executes not exactly line by line, but approximately line by line. So Python doesn't have the ability to look ahead in your code and say, well, like, given that you're going to do this 10 lines from now, maybe I can do something more efficiently right now. It's one of the reasons that compiled languages are more efficient. And also kind of the flexibility that we were talking about in the slide before, in terms of you can go to any address you want, stuff like that, that sometimes allows you to make some shortcuts that enable optimization. So that's one reason to do C. Another reason to do C is that although C code is still not exactly what's going on in the hardware, it's much more like what's going on in the hardware than Python code. So Python code kind of hides a lot of the details. C code is closer to what's actually executed in the hardware. And one reason to care about it is that again, allows you to write more efficient programs. Another reason to care about that is that you need to eventually learn about hardware as well. And 190 is kind of a step towards EC253, maybe. I think it's 253, the hardware course that you take in second year. So that's kind of part of what's going on. Yeah, so in terms, I'm starting up lab solution sessions again, Sundays, 2 p.m. on Zoom or YouTube. So another thing that I would suggest, like if you feel like you're struggling, you can show up to lab sessions at noon prepared with questions. And what they see in the labs when I drop by is that the TAs are quite busy around 2 p.m., but they're just standing around chatting at noon. So that's a good opportunity to get help. And again, the most important thing really is still kind of to practice. So, okay. And I also have office hours, I think Tuesdays at 6, whatever it says on the website. All right. Okay. Questions about logistics? Yeah. When the lab handout, I mean, like usually they go up like Monday morning. I can try to do it Sunday. Yeah. All right. So, okay. So you were asking about the labs, not the projects, right? All right. Other questions? All right. Is there anything interesting going on in Discord? No. Okay. So I want to quickly review this and then move on. So every type of variable takes up a particular number really of bytes. So byte is kind of a slot of data. And that's like that. And as just to remind you, because that's going to be important, something like size of car star means how much memory does a variable of type car star take up. So a variable of type car star is the address of a car. Usually it would be 8. This is hardware dependent, right? Okay, so that's like that. We've done that. So to remind you about arrays and stuff, so you can define an array like this. You can get the size of the array. The size of the array, if you get it like this, is not going to work, right? And the reason is that when you say A here, it gets converted to the address of the first element. Okay, so really this A in any context that's not just size of array right away, that just gets converted to the address. For that reason, I write it as n star A over here. So that means that if you do something like this, and you say size of A over here, this would be, again, hardware dependent, but usually it would be 8 because A here is the address of the 1. It's not the array. Make sense? Yeah. That's correct. So for that reason, if you want the number of elements, what you do is what's the total amount that the array takes up, and you divide by the amount that one element takes up. Yeah.
Curious, is there integer divisions?
Is there integer division in C? Yes, there is. And it depends on, so the question was, is there integer division issues here? The answer is here, it's not really relevant because size of array is going to be a multiple of the size of the first element always. Yeah, like the way integer division works in C is that it's the same operator, but if both of the operands are integers, then it's going to be integer division. But here, not relevant. Yeah.
So basically, if you're trying to find the size of an array with size up, it'll only work in the function where you declare your.
Yeah. So what Michael is saying is, yes, that's one way of thinking about it. Is if you need the size of the array, you can only get it this way if you're doing it inside the function. Well, like inside the scope, I should say, of where this array is defined. Really, there is not almost any time. It's hard to imagine a reason that you would want to do it anyways, because like you've just defined the array. You must know what the size is, right? All right. Okay, so that's size up. So similarly, you can ask for the size of a compound data structure. This. So we can imagine that approximately this would be the amount of space that it takes to store 200 characters plus the amount of space that it takes to store a double. It's not going to be necessarily always exactly that. So just for fun, I'll show you this. So And I'll define a student one like this. That's going to be a little bit dependent on the computer, so that might or might not work on yours. So what, but usually it would. So what you see is that size of a student is, it is the 200 plus the amount of space it takes to store double GPA. So double takes 8 ordinarily. This turns out to be 2016, and that's not because a car takes up 8. It's because it's trying to align stuff. Again, that's system dependent, but it's approximately going to be basically how much does it take up to store this? How much does it take up to store this? So we can look at what that actually looks like. So I'll define like a student S. Alice's GPA is, Alice is an indie, so it's going to be like this. And then Bob is Anxi, so Anxis are better. So we can do it like this. Okay, this is after the return, so move the return over here. Good GPA. All right, so here's kind of what that looks like. So I'll show the memory addresses over here. And what you see if you scroll down is this. So wait, why is it? Oh, sorry. I wanted to make this student 1. And I'll make this shorter just so that I don't have to scroll. So first of all, let's print the sizes. So here, again, this one is 32, this one is 24, even though it's 1 character shorter. And what you'll see here is that here you have this address. So this ends with 0. But this ends with 8. So you're skipping stuff. On the other hand, here you have 16. So this, and again, if you don't know hexadecimal, that's not going to make a lot of sense. But this address is directly before the address over here. Yeah. By 1 byte. Yeah. All right. So we'll do hexadecimal later. So this is just kind of a preview. So the takeaway here is the size of for this kind of struct is going to be approximately how much space it would take to store those separately, because this is how they're stored. All right, makes sense? All right. So we are back to talking about malloc. So to remind you, malloc works like this, right? So malloc is a function that returns an address of a block, sorry, an address of a block where you can write to the memory, right? So essentially, you can think about it as get me an array, but an array that doesn't go away when I return from a function, and an array where I get to dynamically say I want it to be of whatever size. So malloc gets the amount of bytes that are going to be in the block. So if you want, for example, 150 integers, you're going to say, I want times 150 of whatever amount of space that I need in order to store one integer.
Bella would use the store and then it returns the address of like the first.
That's correct. So it returns the address of a block that you could use.
So it allocates that.
It allocates the block, yes. But for now, it's just like the address of a block that you could use. And you can then use it in the same way you use an array, because the way you use an array is you convert this to the address of the first element. So block int is the address of the first element in this block. And here we're saying 7 slots down, put in 42. That's equivalent to saying, get me the address 7 slots down, and then go to that address and put 42 there. Make sense? So let's look at what that looks like in the code. So let's comment this out. Including stdlib. So I'm going to call it my block. Let's say that I want 5 integers. And then I'm going to say my block at 2 is equal to 42 or something. So currently my block, we haven't really initialized it. But now we're saying we're calling malloc and we want an address of something. So what happened now is malloc said, okay, you get to use this address for your block events. So here, Python tutor just displays, okay, like since you're going to be using it, maybe it's displaying it for you. Right. So now if we say my block at 2 is equal to 42, well, it's going to go to this address. And then 2 slots down over here, it's going to write 42. So if I press next, it's going to press 42. Right? Yeah, there's a discussion here that I want to repeat. So the reason you're doing this is that so you can not do it and you'll just get a warning, it's fine. But the issue is that malloc doesn't know that what you need is integers. All malloc gets is this number. It happens that I wrote it as 5 times size of int. And that's usually how I would write it. But it's still, as far as malloc is concerned, just a number. Right? So that means that malloc returns something that's not necessarily in star. So this is saying explicitly convert it, cast it to n star. Yeah.
So it says size of int. Int is a type. Does C know that the type is 4 by 3?
So the question was, does C know that this is supposed to be 4? The answer is C know what it's supposed to be. It's not necessarily 4 on all systems. So it checks on this system what is it that the int takes up. And then because I want to store ints anyway, it works out.
But type inside of the side.
Yes. Yeah, so so the question was you can put a type inside of a size of, and yes, like that, that's it. So you can put both a variable and you can do something. All right, what was it? Sorry, I lost my size ofs. Yeah, yeah, so you can do something like that as well. Yeah.
Malloc is only taking in on a storage side.
That's correct. Yeah, so malloc takes in 1 number, which is just how much space. Yeah. Could we do malloc 20? Yeah, absolutely. You can do malloc 20. So like this number is literally just 20. Like all that that's happened there is like you're computing a number that happens to correspond to 5 integers, but C doesn't know about that. Like this is an arithmetic expression like any other. Does that make sense? All right. So that's the basics of it. So let's just do some examples where it works and doesn't work. So I'll name it like make array wrong. So I'm going to use that syntax. So I'm going to say like int array is 567. And I'm going to say return array. And I'm going to make array right. And that I'm going to do using malloc. And here, I'm just going to do it manually. Like there is like a shortcut to do it, but I'm going to do it later. So you cannot assign 567 directly. You have to do something like this. So here's what happens. So I'm just going to also call make array right. So, and I'm going to do this first. So first of all, this compiles. There's no problem, unless I made a typo. There's no, back to my code. There's no problem with this. The problem happens at runtime. So at runtime, this says invalid right of size 4. And here's why. So if we are over here and we're saying res1 make array wrong, so we're going into make array wrong, we're defining the array. So the array right now exists as this local variable inside of make array wrong. And then what we're saying is return array, so return the address of the first element. And we are returning it, so thus far it's fine. The problem is that res1, this guy, is not actually a valid pointer because that array actually went away. So that means that if you do res1 at 0, then that is just going to crash. Weirdly, at 0, it's not necessarily going to be 0 always. On the other hand, this just works. So if I say res2 is make array right, where do I go inside? Okay. Oh, it skipped. All right, hold on. Yeah, I think I need to restart. Skips this for some reason. Okay, sorry, I'm not sure why it decided to not go into this, but this is fine, right? So this gets the address for array. Oh, now we're here. Okay. So it made this address. So array right now is this, and that's this block of ints. We now put 5 and then 6 and then 7 into here. So this address is this address. Array at 0 is this, array at 1 is this, array at 2 is this. And then we're returning array, meaning we're returning this number, so the address of the 5. And what that means is that res2 here is still the address of the 5. We can go here, we can access the 5. We can also put 123 in here. Make sense? Yeah.
So if you would make array, like it's still passing back a pointer to that element, it's just that's local.
Yeah. So it's that you're passing the so Python tutor apparently doesn't, but in general, yeah, like you're returning the address, but this address is no longer valid because this thing is local. Yeah, ordinarily. Yeah. Because it's not anymore a valid address, right? So, well, like it might or might not still exist, right? So like your any local variable like array exists for the duration of the run of the function. So you're creating this array, this 5 has an address, but after the function has finished running, it's not necessarily going to have any. Yeah, you could make a global variable, yeah. No, it wouldn't be okay because the issue is that this address is not anymore valid after the function has finished running. If it's there, it might not be there. You might not be allowed to access it anymore. Well, while you can take. Well, the issue is that you cannot take the value. Like there is no mechanism in C for just taking a raw array and having the value of that. Like you can have a value of an individual integer, but you can wrap the array in a struct, and then yes, but otherwise no. All right. Okay, makes sense. Questions? All right. All right. Other questions? Okay. All right. So again, kind of local arrays only exist while until the function returns. So you cannot like make an array inside a function and then return it. You can create a memory block in the function, return and use it. So we've done that. Arrays exist while the function is running. Memory that you allocate using malloc, so memory blocks, are allocated until you explicitly free them. So that means that potentially you might run out of memory if you keep requesting memory blocks and not then saying, I'm done using it, so you can use it for something else, computer. To free a memory block, you say free like this. So you say the block that I was using, whose first element is at address res2. I'm done using it, so I'm giving permission to the computer to use this block for something else. So res2 at 0 after that is, again, undefined behavior. So if you try to access a value in a freed block, you might get it, or the computer might crash, might undefined behavior. You shouldn't do it. Right? So essentially, you get to use the block from the point that it's allocated until the point where you free it. So It's good practice to do that. So if you have a program that's running continuously and it keeps requesting memory blocks and not freeing them, you will eventually run out of memory. So that's like one reason that sometimes kind of happens less often now, but you just run out of memory, you need to restart or something. Technically on modern computers, if the program finishes running, all the blocks on modern computers, not on every computer, not on every architecture, but technically if it's a program that just runs and finishes running, then it's going to free everything automatically anyway. It's still a good idea to free, just kind of to keep things neat. For continuously running programs, it's actually important. So a situation where you mallocked but did not free is called a memory leak. And that's, again, on a continuously running program, like, for example, Windows or like, for example, OS X, that's a big problem. Used to be a much bigger problem where you would need to restart at some point because of memory leaks, because there's not any more memory to allocate. On modern systems, less so. All right. So again, this is just repeating what I said before. So if you free a block, you cannot then either access or change block at 0 or whatever. That's undefined behavior. Yeah.
This allows you to use the other stuff, or does it also delete what's current?
It does not delete. So that's a good question. So the question was, does it just allow the computer to use it for other stuff, or does it actually delete the data? The answer is like there's no, so kind of data is stored as like high voltage means 1, low voltage means 0. So that means that there's no deleting. You can potentially overwrite the data if you wanted to in order to not allow others to access it. But at any address, there is data there. It's just a question of does it make sense or not. All right. Okay. So you can have blocks of structs like this. So if I, for example, define this struct that has a 200 character array and it has an H, I can have an array of students like this. Not necessarily the most common usage, because like the only way that you would do it is if you know that you have exactly 500 students that you need to store ahead of time. But how would you know that? And also, you don't need to use this anywhere outside the function. So the more usual situation would be that you would allocate a block of those structs. So it would look like this. Does this make sense? So same structure. Yeah. Yeah. So every malloc should correspond to a free. So this is like a segment of a program. Yes. So eventually there should be a free. So the question is, aren't you taking away? So the answer is like you malloc it, then you use it. Then once you're done using it, you free, meaning that you're not using the block anymore. It can be used for the space that you're used for storing that data can be used for something else. Well, so it's not. So the question is it going to go away? It's not exactly going to go away. That's kind of the same question, I think, as this. So the data by default is still going to be there. The computer might or might not allow you to actually access it if you try. A lot of the time it actually will, which is unfortunate because that means that sometimes it's going to work even though it shouldn't. But it can also just decide immediately, well, like there is this other request for memory, I'm going to use it for that, and then going to overwrite it. Yeah.
Setting aside like 500.
Yes.
Size student.
Yeah.
Main advantages for malloc that you see then free that student later.
Well, no. So the big thing is that this will only exist for the duration of the run of the function, whereas student block, you can actually return from a function and use somewhere else.
So basically malloc kind of shoots when it gets like overwritten. Like
That's right. That's right. So so this you can free right away, or you can like never free at all. This will exist only for the duration of the run of the function. There is, I should say, kind of in the interest of full disclosure, there is another difference, but it's like maybe kind of going too into the weeds for right now about like where, so kind of this is stored in what's called the stack. This is stored in what's called the heap, and the stack might have less space, but forget I said it. So, okay. All right. But like the other thing is like this is like basically inconvenient. And if you try to return students, you won't get an error. It's just that at runtime, the program might crash when you try to access students at 0 outside the function. So ordinarily, you probably should just do this. So it's a very rare situation where you would actually do something like this. So, okay. So that's that. So let's do, I think we're going to do strings next time. I want to do a few exercises. So the exercises are at 190/pointers. So, okay, never mind. So let's do strings first. So strings you've done in the lab. So you can store strings several ways. So just kind of as a review. So you can store a string as a character array. So this is just shorthand for saying that the character array is H and I and 0. By the way, note that string, so the double quote means HI null. Individual characters must be in single quotes. So you can copy strings with strcpy. So you've seen strcpy in the lab. strcpy is also defined in string.h, as you saw. So you can do something like this. So you can say S2 is an address of a car. So if, for example, H is at 1032 and I is at 1033, and the null is at 1034, then saying something like S2 equals S1 is fine. What that will do is it will make S2 be equal to 1032. Right? And that means that S2 and S1 are now essentially aliases. So what that means is that if you modify S1, you'll also modify S2. Does that make sense? So same as alias lists in Python. Yeah.
that are like similar but defined differently. Will it use the same letters or will it like make new ones?
Right. So the question is basically will it do something like what Python does as well, right? Where if you have several string literals, then it'll like try to save space. And the answer is yes, if in general. So that's not behavior that's defined in the language standard. So in principle, there could be a compiler that doesn't do it, but in general, yes, it will try to save space. Now, it won't do that. So it won't, similarly to Python, it's not magic. It's not going to like say, oh, like, I have this new string that I got from the input. Does it happen to be the same as a string that I already have in memory? But if you have two string literals, yes, it'll try to save space that way. And that's part of why when you so here we haven't done it, but if you say, S equals to high, then the high is a const star, so you're not allowed to multiply the contents because there might be aliasing there. All right. So the reason I'm bringing all of this up is to highlight the difference between strcpy and something like S2 equals S1. So S2 equals S1 makes it so that S2 is the address of this H, right? So this makes it so that S2 is 1031. On the other hand, this is different. This is saying take every character from S1 and copy it to S2, S2 plus 1, S2 plus 2, and so on. Can you do it right now? No, you can't, because right now, well, given the code as it is right now, S2 is 0. 0 is not a valid address. Is that making sense so far? So, like, does it make sense that this would crash right now? Does it not make sense that it would crash? No? Yeah. Then you'd have a problem. So, or rather, you'd have a problem when you do strcpy. So, if you're doing this, then it's completely fine, because all it does is just copies 1032 over here. But yeah, strcpy does not check that there is enough space in the destination, which means that yeah, like it would cause problems. Yeah.
Why would that one crash exactly?
So it would crash because S2 is equal to 0 right now. 0 is not a valid address. So we not malloc S2. We just said S2 is the address 0. So this is saying, like, copy H to address 0 and I to address 1 and null to address 2. None of those are valid. You can, however, say, I want S2 to have enough space to store the string S1. So why is it plus 1 there? Yeah. So not just in case, it's definitely there, right? So strlen S1 is the number of non-null characters in S1. And in order to store a valid string, what I need is all the characters from S1 and then a null. So how much space do I need? Well, I need whatever amount it takes to store one car times the length of S1 plus one more for the null, right? So now S2 is going to be a valid address where I can copy every character of S1 too, right? So that. Not happy about something. So that is a problem as predicted. Have 30 more seconds. So right now, S2 is nothing. I can try to it, but once I've allocated it, now S2 has 3 spaces somewhere. So starting from here, and strcpy from S1 to S2 just copies things character by character. So it copied the H over here and the I over here and then L over here. So now that's fine. Yeah. All right. Thanks very much. I'll answer your question if you come up. All right. See ya. Bye.